Today we are going to solve one problem using method of resolution of forces. So here in the problem, a body is subjected to the following system of forces. First one, a pull of 8 kilonewton towards east direction, a push of 3 kilonewton towards northeast, a pull of 5 kilonewton acting at 30 degrees towards north of west, a pull of 6 kilonewton inclined at 30 degrees towards east of south. So here push means pulling force and pushing force. So when a force, so here we are considering a point when a force acts away from this point, then this force here we are calling pull type, and here we are going to consider this pull type of force is positive. So here the sense or nature of the force is away from the considered point. So when the force is acting away from this point, then this is called pull type of force. So that pull type of force here we are considering positive value. So in push type of force, the force acts towards the point. So this is the point here we are considered, and a force acts towards the point, then this type of force is called push type of force. So here the sense or nature of the force is towards this point. So this push type of force we are considering negative value, because here we considered pull as positive, so that's why the other one will become negative. So here so a pull of 8 kilonewton towards east. So if we observe in the problem, then we the data has been given that east direction, northeast, northwest, east of south. So first we should understand what are all these directions. So the number of various forces are acting in different directions. So according to that data, we have to draw the direction of the forces, so that we can easily calculate resultant. So here the question is, we have to find out the magnitude and direction of the resultant. So we have to determine magnitude and direction of resultant. So our goal is we have to find out magnitude and direction of the resultant. So for that, the problem, so this data has been given. Using this data we have to draw how actually the various forces are acting. So for that, first we should understand these different directions, how actually the meaning of all these. So normally we already know that 4 directions. Those are so this is east direction. So if it is east, then this one is west, this one is north, and this is south. So we have mainly 4 directions. So if any force acts towards east, then we have to draw a force in this east direction. If in the problem it has been given that in north direction, then you have to draw force directly in this north direction. Similarly in west and south. So the angle between this north and east is 90 degrees. The angle between north and west is 90 degrees. West and south is 90 degrees. East and south is 90 degrees. So if any force acts towards northeast or towards northwest or towards southwest or towards southeast, then we can write like this. So northeast, so this is east, north, west, south. Northeast means if any force acts exactly in middle between this north and east, then it is called northeast. So a force so northeast. So if in the problem, it has been given that northeast means a force is acting exactly in a middle way between north and east. So in the problem, a push of 3 kilonewton acting towards northeast. Here he didn't mention any angle. So how much angle it is making with the horizontal, that it has not been given, but indirectly we can understand that the angle is 45 degrees, because northeast means it is exactly middle between north and east. So this angle is 45 degrees. So this northeast is going to make angle 45 degrees with the horizontal line, or it is going to make 45 degrees with the vertical line, because it acts here in middle. Similarly, in the problem it has been given northwest. So northwest means exactly middle between north and west. So this is northwest. Similarly, this is south and west, southwest. So here also it is 45 degrees. So in the problem he is not going to give this angle 45 degrees, but we have to understand that indirectly he has been given 45 degrees, because this northeast or northwest or southwest, they are acting exactly middle in between those directions. So this is southwest. So it is going to make angle 45 degrees with the horizontal or 45 degrees with the vertical. Anything you can write. And this one is, so this is south and this is east. So southeast. So it is going to make angle 45 degrees. So 45 degrees with the horizontal or 45 degrees with the vertical. Anything you can write. So northeast, northwest, southwest, southeast. Okay. Now one more terminology is there: north of west or east of south. So what is the meaning of this terminology? So if any force acts from north of east or south of east or east of north or west of north, if anything it has been given in that, then that means, for example, this one is east. From east to this direction is north. So from east to north, if you move, then it is called, how we are going to say this one, north of east. So north of east. So for this is east direction. So what is the north of east means? You have to move from east to north direction. So north direction is in this way. So from east to north you are moving. So north of east. So if any force acts some 30 degrees towards north of east, or 40 degrees towards north of west, or 60 degrees towards north of east, if it it has been given like this, then that means a force is going to make some angle in this direction, so north of east. So if any force acts towards south of east, then at that time you have to draw this side. You have to draw this south side, because this is south and this is east. So south of east means you have to move from east to south. That means you have to draw a force in between south and east with an included angle which has been given in the problem. So this direction is south of east. So if it is 20 degrees, then with the 20 degrees angle you are going to draw a force which is going to make 20 degrees towards south of east. So here you are going to draw south of east. So south of east means you have to draw in between south and east with the included angle which has been given in the problem. So north of east means you are moving from east to north. South of east means you are moving from east to south. Similarly, in the problem it has been given if any force acts towards west of north. So this is north. West of north means west direction is this side. So you have to draw a force here with an angle. So whatever the angle it has been given, with that angle you have to draw a force like this. So west of north. So this direction indicates west of north. So this direction indicates east of north. So you are moving from north to east. So this is north and this is east. So you are moving from north to east. So in our problem it has been given acting at 30 degrees towards north of west. So north of west means first we have to consider west. So this is west. North of west means west direction is towards this side. So you have to draw a force here. So this direction indicates, so here the include angle, so some 30 degrees. With 30 degrees you have to draw a line here. So this indicates north of west. So in this direction, so in between south and west if you draw any line, then that is south of west. South of west. So if you are moving from south to west, then it is called as west of south. So if you are moving from south to east, then this direction is called east of south. So this is the meaning of north of west or east of south. So this is the concept of different directions. So from the problem we have to draw directions of different forces. So further here yes, so east, west, north and south. So first one, if you observe, a pull of 8 kilonewton towards east. So this is the point. Here we are considering a pull off, so pulling force. So you have to draw away from this point towards east. So it has been given that towards east. So in east direction we are drawing. So this is 8 kilonewton. So this force is 8 kilonewton. Next, a push of 3 kilonewton towards northeast. A push of 3 kilonewton towards northeast. Northeast means this is middle, so this is northeast, and he is saying a push of 3 kilonewton. Pushing force means towards this point, so we have to mention the direction of force towards the point. So this is 3 kilonewton. See, 3 kilonewton towards north east. So this is northeast direction. That means the included angle. So it is going to make this 3 kilonewton is making an angle 45 degrees with the horizontal. So indirectly it is making an angle 45 degrees with the horizontal. So next one, a pull of 5 kilonewton acting at 30 degrees towards north of west. So a pull of 5 kilonewton acting at 30 degrees towards north of west. So north of west, that means from west to north. So and it is making an angle 30 degrees. So you have to draw a line in the region between north and west. Okay. So it is, he is saying pulling force only, so away from the point. So the direction of the force is away from the point, and this force is 5 kilonewton, and it is making an angle 30 degrees. So it is making an angle 30 degrees towards north of west. That means from west to north you are moving. So here you are going to draw a line. So this is north of west. After that, a pull of 6 kilonewton inclined at 30 degrees towards east of south. East of south means from south to, so east of south means this direction. So from south to east you have to move. That means you have to draw a line in the region between south and east. Say a pull of 6 kilonewton, it is making an angle and it is inclined at 30 degrees towards east of south. So this one is 6 kilonewton. So from south to east we are moving. So that is called east of south. So east of south. From south to east. So this is east. From south to east we are moving. And this angle has been given that 30 degrees. 30 degrees. So a pull of 6 kilonewton is inclined at 30 degrees towards east of south. So that's why from south to east we are moving. So here included angle is 30 degrees. So this is the diagram of different direction of forces. So various forces are acting at a point. So here we have 6 kilonewton, 5 kilonewton and 8 kilonewton. These are pulling forces, and here we have 3 kilonewton is a pushing force. So for easy understanding, what we are going to do means, so here we are going to draw this 3 kilonewton pushing force like this. So this is 3 kilonewton. It is making an angle 45 degrees. So we can extend this line like this. This is 3 kilonewton. So if this is 45 degrees, this one also becomes 45 degrees. So these two angles are same. From mathematics we already knew that. So what we are doing means we are extending this 3 kilonewton force to another quadrant. By doing this, the effect doesn't change. So instead of drawing like this, what we are going to do means here we are going to draw 3 kilonewton force like this, so that we can, while calculating, we can easily calculate without confusion. So here on another page we are going to write so this is 8 kilonewton. So 3 kilonewton we are drawing like this. So instead of showing here in the first quadrant, we are showing in the third quadrant with an angle 45 degrees. So the effect doesn't change. And here we have 5 kilonewton with an angle 30 degrees. And also we have 6 kilonewton. So in the problem, so with the vertical line it is making an angle 30 degrees, but all the remaining forces we are showing making angle with the horizontal. So that's why if the 6 kilonewton is making an angle 30 degrees with the vertical, means it is going to make angle 60 degrees with the horizontal. So if this is 30 degrees, means this one will become 60 degrees. So what here we are going to draw here means here we are showing the 6 kilonewton is making an angle 60 degrees with the horizontal. So now, so all the forces are making an angle with the horizontal. To get uniformity, just we are writing like this. So with the angle 30 degrees to the vertical also you can calculate, but for easy understanding and to get uniformity, here all the forces we are showing that all the forces are making an angle with the horizontal. So from this diagram, by applying method of resolution of forces, from method of resolution of forces, resultant R equal to under root of sigma h square plus sigma v square. So algebraic sum of all the horizontal component square plus algebraic sum of all the vertical component square. So if you under root this value, then you will get magnitude of the resultant. So this is magnitude. And for direction, theta equal to tan inverse of sigma v by sigma h. So we already discussed about this. So this is direction. So first of all we have to find out sigma h, sigma v. So sigma h means algebraic sum of all the horizontal components. First, for force 1, 8 kilonewton, horizontal component is 8 kilonewton only, because 8 kilonewton is acting, so it is directly a horizontal force. So the horizontal component of 8 kilonewton is 8 kilonewton only. It doesn't have vertical component because it is a horizontal force. It is not going to have vertical component. So it has only horizontal component. That horizontal component is 8 kilonewton. So this 8 kilonewton is acting positive x-axis direction, so that's why here we are considering this as positive. So here other force is 5 kilonewton. So the horizontal component of this 5 kilonewton is the horizontal component. So it is making an angle 30 degrees with the horizontal. The horizontal component will become 5 cos 30. So 5 cos 30 and this 5 cos 30. So here the horizontal component will become 5 cos 30 and vertical component will become 5 sin 30. So if one is horizontal cos, automatically other one will become sin. And this 5 cos 30 horizontal component acts in negative x-axis direction. That's why here we are taking minus 5 cos 30. So this is horizontal component. And coming to for 3 kilonewton, the horizontal component of 3 kilonewton is, so it is making an angle 45 degrees with the horizontal. So that's why 3 cos 45 is horizontal component and the vertical component will become 3 sin 45. So it's in downward direction. So 3 cos 45 is horizontal component of 3 sin 45 is horizontal component of 3 kilonewton. So this 3 cos 45 also acts in negative x-axis direction. That's why we are giving minus 3 cos 45. After that 6 kilonewton. So it is making an angle 60 degrees with the horizontal. So that's why horizontal component of 6 kilonewton will become 6 cos 60 and vertical component will become 6 sin 60. So this 6 cos 60 horizontal component acts in positive x-axis direction. That's why plus 6 cos 60. So if you calculate this, then you will get 4.55 kilonewton. So using calculator, if you calculate, then you will get this answer. After that, sigma b. So algebraic sum of all the vertical components. So first force 8 kilonewton. For 8 kilonewton force, so it is a horizontal force. So it is not going to have vertical components. So that's why 0. After that, for 5 kilonewton, we have a vertical component 5 sin 30 and it acts in positive y direction. So that's why plus 5 sin 30. After that 3 kilonewton, for 3 kilonewton we have vertical component 3 sin 45 and acts in downward y direction, that means negative y direction. So we are taking minus 3 sin 45. And here for 6 kilonewton we have vertical component 6 sin 60 and it acts in negative y axis direction or downward direction. That's why minus 6 sin 60. So if you calculate, then you will get an answer minus 4.81 Newton. 4.81 kilonewton. So it is kilonewton. So finally magnitude of the resultant R will be equal to under root of sigma h square plus sigma v square. So under root of 4.255 whole square minus 4.81 whole square. Then you will get some 6.62 kilonewton. 6.62 kilonewton. So this is magnitude and direction of the resultant theta equal to tan inverse of sigma v by sigma h. So tan inverse of sigma v is minus 4.817, sigma h is 4.55. 4.81. Okay. 4.81 by 4.55. You will get theta equal to minus 46.63 degrees. Theta you will get minus 46.63 degrees. So here sigma h 4.55 kilonewton, so positive. Sigma v minus 4.81 kilonewton, so minus means you have to draw downward direction. So this is sigma v. So the resultant will be here. So this resultant is making an angle 46.63 degrees. It is making an angle theta equal to 46.63 degrees. So this is east and this one is south. So direction of the resultant here, resultant is acting 46.63 degrees towards south of east. So this is east, so resultant is acting 46.63 degrees. So this is south, so from east to south, from east to south, that means south of east. So resultant is acting at an angle 46.63 degrees in a direction south of east. So here minus represents, here sigma v is in negative y direction, so that's why this negative value represents negative quadrant or negative y-axis direction.